Okay, let's see how to solve this problem. We have got mass of 8 kg which is placed on an incline at an angle of 30 degrees. So this angle is given as 30 degrees, that's theta equal to 30 degrees, and the mass is 8 kg. Now it says a force of 50 Newton is applied, and it is applied as shown in the diagram. We can see that this is your 50 Newton force. So F applied is given as 50 Newton. It's on the box and it's trying to push the box upwards. And then it says the box is moving at a constant velocity, which tells us that the acceleration of the box along the plane is equal to 0. So that's the acceleration of the plane of the box along the plane. Okay, so we know that in inclined plane we have to think about along the plane and perpendicular to the plane. So acceleration along the plane is given as 0. Now it's asking us to find the component of the weight along the incline. So before we do any of these, we have to draw the free body diagram on the inclined plane. So let's do that. So we'll have the gravity force acting vertically downwards, which will be given by mg, vertically downwards. Then we have to check if it's a smooth surface or a rough surface. For that, if you see in part C is asking for kinetic friction, that means it is a rough surface. So we have to show the force of friction opposite to the direction of motion. That's our friction force, and we'll write it as FF. Okay, the object is moving upwards, so the friction is acting downwards. Then we have to show the normal force which will be acting in this direction. This is our normal force Fn, vertically upwards, not vertically upwards, perpendicular to the plane along the y-axis. Now we want to find the component of the weight along the incline. That's the first part. Okay, so our free body diagram is complete. We have got the normal force, we have got the force of gravity, we have got friction and the applied force. Now before we move ahead, we can see that is asking for component of weight, and we know that if there is any force which is not on the x-axis or the y-axis, it has to be resolved. That means we have to find the components of it. So we are going to find the components of this force, and let's just do that. This component, as we know that, it will be mg cosine theta. So in this case it will be mg cosine 30, because the angle will be 30 here. This angle is 30. So that's the component perpendicular to the inclined plane. Okay, and along the inclined plane we'll have another component which will be like this. That's our component along the inclined plane. So that will be written as mg sine theta. So now it's asking for the component of the weight along the incline. So this is our weight, and along the incline the component is mg sine theta. So that's what we have to write here. We'll write it as mg sine theta, which is along the plane, where m is, we know it's 8, g is 10, and theta is 30, so sine 30 degrees, and we can use our calculator. We can get the answer as 40 Newton. Next is asking what is the magnitude of kinetic friction acting on the box. What is the magnitude of kinetic friction? So now we want to find out the value of friction. So for the value of friction, we have two ways to do it. Either we can apply the Newton's second law, or we can use the formula for friction. So we have to check which one we can apply here. So we will just first write the formula for friction, which is given as mu Fn. We can see that the value of mu is missing here. That means we can't use this formula. Instead, we are going to apply the Newton's second law. So sigma F equal to ma, and we are going to apply it along the plane because the friction is acting along the plane. So the net force along the plane, if we see, there are two forces which are acting along the plane, actually three forces, which is mg sine theta, the friction, and there is one applied force which we can see here. Okay, now if you can't see that, I will just draw it once again here to show what are the forces along the plane. So we have got, this is our mass. Okay, we had an applied force F acting on it, and we have a component of mg, which is mg sine theta, which is acting this way, and there is one more force, which is the friction force, which we can see. This is your friction force. I'm just drawing it with the yellow color. So that's our friction force. So there are actually three forces acting along the plane. One force is upwards, that's the applied force, which is in the same direction of the acceleration, and the other two forces are downwards. So we will be having F minus mg sine theta minus ff, which is the friction, equal to ma. But we know that the acceleration is 0 along the plane, so that means I can write it as equal to 0. So now we can solve this and substitute the values. Let's do that. So just a minute. Okay, so we can apply the values here. Force F is 50, mg sine theta, which we calculated in the first part, which is 40, minus ff equal to 0. So if we calculate this, we can get the force of friction as 50 minus 40, which is equal to 10 Newton. Now we want to find the coefficient of kinetic friction, that is, we want to find the value of mu, which we can see here. If we see here, this is the formula of friction, from where we can write mu as friction divided by Fn. Okay, now friction, we already have the value for friction, which is 10, and Fn is not known to us. So what we will do, we will look at the y-axis. So this is our y-axis, which is perpendicular to the plane. On this plane, the object does not move up or down. That means I can write sigma f equal to 0 along the y-axis. Okay, that is perpendicular to the inclined plane. And we have two forces acting along the y-axis, which is Fn and mg cosine 30. So Fn is upwards, so Fn you'll write as Fn positive minus mg cosine 30 equal to 0. Which we can calculate, and we can get the value of Fn as mg cosine 30. We can use our calculator to get this answer, and let me see, we get it as 72. So I'll just rub this out and write here 72 Newton. Now this value, we can put it back in place of Fn, and we can get the value of mu as 10 over 72, which will come out as 5 over 36, and you can calculate it in decimals and get the answer there. So that comes out as 0.14 without any units, no units for it. Then it's asking us, as angle theta is increased, so this theta, that is 30 degrees increase, what happens to coefficient of kinetic friction between the bottom of this box and the surface of the incline. So it's asking what's the value, how is mu affected if we change theta. Now mu is depending on the type of surface So as long as we don't change the surface, we can see that we have the same surface which we are using. Just by changing the angle, the surface is not going to change. It will remain as smooth or as rough as it was before. So there will be no effect on mu. There will be no effect on mu.